If we look at different materials on the Earth's surface, we'll notice that they have different colors. We can also think of this as different reflectances that are a function of wavelength. So for example, grass is green because it reflects more green light than it reflects red and blue light. Santa's underwear is red because it reflects more red light than green or blue light. If we want to put this on a graph, we can show it on a two-dimensional plot in which we have wavelength denoted by lambda here, and we have reflectance, capital R, here. Reflectance ranges from 1 to 0. 0 is zero reflectance, so you can imagine a surface that's perfectly black. 1 is perfect reflectance, in which all the incoming light is reflected back up. So that's a perfectly white surface. The range of wavelengths that we want to consider depends on the sensor and the material that we're interested in. But for now, we can start to look at maybe the visible wavelengths over here. I'll write a little B for blue, green for G for green, R for red, and we can go into the near infrared over here. And we can keep going if we have materials that have interesting features over in the longer wavelengths. So if we want to plot grass on this graph here, we could say that grass has maybe, let's say, around a 15% reflectance in the green spectrum, and lower in the blue, maybe around 10, and also around 10 in the red. So we can create a graph that looks something like this here. And then grass actually has a very high reflectance in the near infrared. So we might get up to something like 50% reflectance once we get into the near infrared. Snow, as you know, is highly reflective across the visible wavelengths, so we might be up at 80 or 90% here, and then it actually goes down slightly as we go into the near infrared. Water is not highly reflective, but relatively speaking, it reflects more in the blue than it does in the green, typically, or about the same, and then much less in the red, and effectively goes to 0 once we go into the near infrared. So these patterns are all very different for different surface types. I'm just going to write vegetation here, water, and snow. You could add a lot of lines to this, different soil types, asphalt, all kinds of surface types that you can imagine. The interesting part here is that these patterns are relatively unique to each surface. So if we see a pattern that looks like one of them in an image, we can guess at what is probably in that image. The important part is that these spectral signatures, they're defined in terms of the surface reflectance of each material. So I'm just going to add a little bit to the description over here, surface reflectance. This is an added reason why we want to typically work with surface reflectance data when we're looking at remote sensing data, so we can compare directly the values that we're seeing, for example, in a pixel in different bands versus the values that we think we might be seeing if we have, for example, snow or water on a surface. So if we have an image in which the surface reflectance is around 10% in the blue band, 15% in the green band, 5% in the red band, and then 50% in the near infrared band, we can be pretty sure that we're looking at vegetation because nothing else has a signature that looks exactly like that.